Okay, we come to one of the very interesting sessions, more towards visual. You get to see a lot of things. Uh, so far, whatever we have been talking about, be it visual astronomy and all those, you have to be there in the place to experience it. Of course, to make astrophotography or to do that, also you have to be there. But at least I can show whatever we have taken at different places and connect to some stories. So, how many of you are interested in pursuing something like astrophotography? Okay, seems quite a bunch of hands. I think after we see this and I ask, maybe the number of hands raising will increase. Like so. Okay, so this will be our agenda. So I will introduce you to astrophotography and what are the types and how do we do the imaging and what really we do at the spot, and also show you some beautiful images taken by the BAS members. And Subhendu will introduce you to how to make star trails. He will do a live demo of with the images that he has or the raw images that he has. He will show you live how to make star trails, and we will show you Milky Way time lapses. But yeah, Mahadev is not here today, so maybe Vinay will take it, or yeah. Oh, sorry, Snehith will take it. Sorry, I just saw Vinay and told Vinay. Yes, and basic image processing. Again, Snehit will also show you after we had taken the images, how do we do the image processing to really come to a level where it's beautiful to see. We'll also show a small live demo in a Snehit will. And after that, of course, the Q&A, we are here to take any questions. Okay, so it's 12. So what is astrophotography? I used to keep it very simple. It's an art of capturing the celestial bodies using various techniques of various equipments that's really needed. An amateur setup, like when you say amateur photography, it could vary, or the range of the equipments that you have to use could vary just between a small DSLR, a tripod setup, like the ones we use in our conventional astrophotography, to a very, you can set up an image, complete photography setup inside of a dome in a place like Chile and then operate remotely from India. People are also doing it at the amateur photography level. And there are companies that have such setups. You can rent it, you can image it remotely, take those raw images, and then do the processing at your home. This is also possible. So what are the basically major components, not just of astrophotography workflow, in any photography workflow? We take images, and before we upload into Instagram, we do some filtering or some image processing, right? And then we upload. So that's the same here also. So we do an image acquisition, and also we have to do some photo post processing for that. We'll look into it in detail. This, what I'm now we are trying to see is the types of astrophotography. Okay, so this is a very broad classification so that we understand or just map in our mind that okay, we can just classify almost all types of astrophotography into these four main categories. So first is landscape AP, meaning at the landscape level, we'll have a foreground and a background, and then we'll have the Milky Way. It's a wide field of view photography. So that's the landscape. Examples are Milky Way, time lapses, and then some panoramas. Next is the planetary and moon photography. Of course, these are also celestial bodies like the other objects in the sky, but we keep it special because the techniques that we use for planetary and moon is different from the other types of astrophotography. Basically, planetary meaning all planets, moons meaning our moon and the other moons, satellites, and of course comets. Occasionally, they visit us, and that time every astrophotographer jumps into the eye to does the imaging. DSO imaging. This is one of the probably the complex of imaging that's there out of these four topics. So DSO imaging requires a lot of patience, skill, equipment, and on all of the above luck, meaning the cloud. It has to be a clear sky, it has to be a dark sky, yeah, right point, and also money for buying those equipments and stuff. Okay, and of course, special events. What do you mean by special events? So eclipses don't happen every day, and conjunctions, meaning two celestial bodies being in the same field of view. So if I look into a eyepiece of an object and I see, okay, I can see two planets together in the same time. Those are termed as conjunctions. So these are all special events. They don't happen every day. They're not there normally. We come to know that such events are happening. We prepare ourselves and be ready to capture witness. So these are termed as special events. Without further ado, I will try to show you some images that we have taken from the past. But before that, so what's when I talk about landscape? If you see, this is a very typical, simple setup that's needed for the landscape astrophotography. So you need a tripod, a good DSLR with a wide field lens, something like 18 to 50 mm, and of course an intervalometer. Anybody knows intervalometer here? Guys are here, have heard this term? So see, an intervalometer can automate the images that you're taking. For example, you will have to set up exposure, aperture, and the ISO, the triangle of the imaging process, right? You can set it up, and then you can ask the camera to take it, say, for example, 100 times. Iterate it for 100 times. Take it for 100 images. So all these settings can be done using an intervalometer that's connected to the photography setup. I will tell you why we'll have to take so many images and what we'll have to do. This we will discuss as we see in the next coming slides. Okay, so this was taken by our past member Mahadevan. What do we see here? What is this? Summer arm or the winter arm? Summer? Ponder about it. We'll come back to it. Okay, so this was taken with a DSLR and with a lens that was 18 to 35 mm variable lens at f-stop at 1.8. So this is a very typical this kind of a setup that was used. Very simple setup for this. But what's the additional things that we have done here to take this? We have been to a very dark place. Like Nandan just mentioned in his talk that we have access to certain dark places in South India. So this was taken from Coorg, where we used to have our star parties. So yes. Okay, what do we see here? Any guess? Okay, now let's split this into two. This is the foreground, right? Whatever we have that's on the earth, this we are clear. And the above is the sky part, yes. So we have some setup here. What is this? Has anyone seen this? Yeah, that's there. Okay, the light part is of course zodiacal light. So there's a structure here, a building structure. It's the Mace Observatory. Is it exactly Hanley or what? It's at Hanley only, right? It's not Mace. Uh, Hagar, yeah, it's Hagar. Sorry, this is the Hagar at Hanley. Okay, this is another Milky Way image that was also taken by Mahadevan in Coorg. And Mahadevan is a specialist. He always takes Milky Way images. That's why you see most of our Milky Way images are sourced from Mahadevan's repository. Yeah, different Milky Way images. Okay, here comes another image. So this is also a wide field image. This was taken by Subhendu. We'll also come to stage later and explain you about how to make star trails. So this also was taken by a typical setup, but a little complex setup than what we saw before. So you will see here there is a yes, this is this setup whatever we are seeing here. Okay, this is the combination of exactly the one which we are seeing. Yeah, this is the setup. So what we have here is the camera, the lens, and of course a star tracker. This will help us to track and counteract to the Earth's rotation. And to the camera, it will be like the image, the light it's getting is from a still or a stationary object. So this helps us to make the long exposures. I'll tell you why we will need it. So let's probably delve into it a little once we look into the other setups. So this is now with an additional tracker that will help us to counteract the Earth's rotation. And what do we see here? What do we see here? What is this and what is this? Okay, I'm actually doing it. It's not coming. Okay, there is the okay, thank you. So you see something here and you see a nebula here. Can you identify? Do you know what these are? Yes, that is the Orion Nebula, and this is the Horse Nebula, Horsehead Nebula. Sorry, yeah, this is the Horsehead Nebula. I'll also show you some zoomed in or a different images that we have taken of these two nebula separately. I'll show that as we see later. So now coming to the moon and the planetary epi. See what we do here. So this is typically my first time. This is actually my setup. I use this setup to take images of some planets and the moon. I'll show you subsequently. And this is the telescope. This okay. This is the telescope. This is a Schmidt-Cassegrain telescope. This is a telescope, and this, if you remember, somebody was telling that we can. There is an automated telescope. We can just punch in the coordinates, and then the telescope will point directly to where we want to see. So this exactly does that. So here you have the remote, or say the built-in database of all the almost 40,000 plus celestial objects keyed. So you just have to punch in the coordinates, or you can even punch in the Messier catalog numbers or the NGC catalog numbers or all any catalog number, and then we can directly ask the telescope to go there and check it out. This is also possible. I use this setup, and what you see here is an eyepiece tray. So all my eyepieces are here. So actually, I was using this for visual. If you see, there is no camera at all here. So what we used to do is here we used to remove this eyepiece area, and then we just connect the DSLR here, and then we can do the imaging. And of course, all the other accessories are mine and has no relevance to this image. Okay, this was taken by one of our fellow batch members, Mr. Sukumar, and he used a similar telescope and used his phone, Samsung M30s, connected to the telescope. This is called lucky imaging. We put the camera on the eyepiece and then try to take the image. Okay, yeah, just another view of the same from the same setup. Okay, this is the image of Saturn, which I took. One good advantage of doing planetary imaging is that you can do it even from the light polluted skies of any city. This was done from the center of this image was taken from Chennai with full light pollution, just like as we have it here. And but I used a specific camera that's used for planetary photography. It's called as AWE2024 and the same telescope setup that I showed you in the previous photo. I used this. There is a small there is a small double layer kind of a thing. You see that here on the edges, like something just you recognize this. Do you see this? Is it visible to you guys? Yes. It is because of the atmospheric dispersion. So since the light has to travel through the atmosphere and that atmosphere has its own reflective capabilities, because of that, you see that the small thing coming over the image in itself, and it is not an artifact of the setup, or it's not an artifact that has come because of it. It's purely because of the atmospheric dispersion. Okay, and here we see that there are yeah, this is a Jupiter image that's taken by Raghul using a 130 Newtonian telescope. Uh, the 6-inch telescope just now what Vinay showed you, right? It works, it's the same telescope. And QHY5, the 512 is the model of the camera that he used. So you see here, what all do we see here? Right spot, good. So this is the GRS. You can see here the GRS, the great red spot is here. And of course, something here. These are they some artifacts or do you think they are something else? Yes, they are the moons, but I don't remember what they are right now. Okay, so he has got two moons and he has got the GRS in this image. Okay, so let's talk a bit about DSOs, and I will show you the so far whatever DSOs we saw in the previous imaging were all from the wide field setups, right? So now I will show you something that's what we do is we kind of project or take images of individual galaxies, nebulas, and then try to frame it in a closer, relatively closer shot. I will show you how we do it. So before that, we will see how what we really need for this. Okay, so and how the why the setup is looking complex. So before we go into that, I'll give a small introduction and then connect you to that image where that entire setup is there. Okay. So of course, for capturing any image, what do we basically need? We need the camera, right? So here I have put two types. One is the DSLR in itself, and especially astro imaging camera. Of course, we can do astrophotography with DSLRs. There are wonderful pictures that have come out from DSLRs, but still, there are astrophotography cameras that's existing in the world for few reasons. Okay, what we know is DSOs are very faint objects. We all agree with this. We don't see it naked eyes, even if you are in the darkest of places. We don't see all the DSOs with naked eyes. Of course, Andromeda is something we can see, maybe Orion Nebula is something we can see, but not every of them can be seen with our naked eyes. Why? Why don't we see it? Let's say I am at the best of the skies, but I still cannot see Hassel Nebula with naked eye. I know where to see, but I don't see it. Why? Yes, and it's very weak. The photons are very weak. They are very faint objects to see with naked eyes. Right? Unlike planets that you can just see it with your naked eyes, recognize them. It's not possible for all the DSOs. So the astro imaging so that means what does it mean is when we take an image of even with a DSLR, we have to do long exposures. Probably expose the imager for 3 minutes, 2 minutes, 5 minutes, and then take an image. Okay, only then you see that the DSO DSOs are coming as images to you. Okay, so for that, of course, DSLRs can also do it, but DSLRs are not designed for this. DSLRs are designed for portrait or any other normal photography for which we will not set the exposure for 5 minutes. We don't do that in the conventional photography. This means the DSLRs will be, if we can still do it with the bulb mode that we have in the DSLR, but what happens is it ends up getting heated and it kind of generates more noise during this time. So these astrophotography or say the special device, whatever I'm showing here, the the camera, this is also working in the same principle as the DSLRs. In fact, they have the same images that's part of the DSLRs. But the only thing is they will have additional cooling capabilities, meaning there'll be a cooling fan here, and also we'll have some seabed strips which will reduce the temperature. So we can bring the temperatures down to negative temperatures, -10, -15. We can control via our interface and bring the temperature lower. This means that the thermal noise is really reduced. Likewise, there are multiple noises that will occur because of the long exposure, and the astrophotography cameras are designed so that they are capable of reducing that noise. That's why you see that there are special cameras for astrophotography. But does it mean that we cannot do anything with DSLR? Absolutely not. We all started with the DSLR, and then later when we found that we have reached the limit, and that's when we started venturing into astrophotography special cameras. Okay, now in order to collect the light, now the imager is where the light falls on, right? We have to put but how do we collect the light? Just like in the morning, Akash was mentioning about the light bucket, right? The more bigger the bucket is, more light can be collected. But on the other hand, if I'm able to keep the bucket outside for a longer time, that means I can collect more raindrops, right? The keeping it for the longer time is nothing but exposing it for a more time. So what we are doing is, so that means that we will also need a lens, a conventional lens, the telephoto zoom lens is also okay. or a special telescope that we use for photography. There are again very similar to what I discussed about cameras and astrophotography special camera. Telescopes also, and we have certain telescopes that fall into a category called as APO. Those telescopes will help us to align the colors in the same plane, avoiding fringes. So in a image, if we have you seen images in or I don't know, since we saw sun, I don't think you have observed it. When we see bright objects over binoculars, small normal binoculars, we will see fringes on the edge. The edge will have some coloration. If there is moon, the edge of the moon will have some colors like blue, green. But there will be a small tint. So in order to avoid this tint, probably during visual is fine, but if I'm exposing it for a longer time and trying to record this as images, then this fringe will become very evident and visible. So in order to avoid that, there will be color corrections done using multiple lenses inside, and this makes the setup a little more complex. And this setup is used for astrophotography. So that's why you will have special dedicated telescopes that's used for astrophotography. So we know that we need camera, we need a telescope, and of course we need the mount. So whatever I've shown you is exactly this mount what we have here, this white one, right? This holds that entire telescope, and this also helps us to track and rotate. So what we can do is basically as a when we do astrophotography, we kind of point the telescope towards north, align, and start tracking. So even the morning when we are seeing the solar activity, you saw that one of our setups, that setup was tracking, right? So we know that the Earth is rotating, meaning that if we wanted to expose it for 5 minutes and take an image, and if I'm not, if the Earth is rotating, then if I expose without doing any counter action, what happens is I don't get a clear image. The object would have, or say the celestial object, like say, or if you are targeting Orion Nebula, the Orion would have moved a bit. That means I cannot get a clear image. I will only get a moved image. So in order to counteract for the Earth's rotation, we will need a specially designed mount like this. This mount actually contains motors and has interfaces that we can connect to an external computer or a small Raspberry Pi kind of a device, and then we can automate the way it has to set up, and then we can make it track the object that we are trying to image. And that this without this exposing the camera for 5 minutes will not lead us to the beautiful images what we see. So that's the real need of this mount. Of course, the platform to hold the entire setup. So the platform to hold the entire setup. This is needed. This is right now what you're seeing in the front is a typical astrophotography setup. This is called a German equatorial mount, and it can, based on its payload, you will see small setups with a similar principle going beyond this size also, that can hold as payload, and then in order to have a larger light bucket, if you have a larger light bucket, larger telescope, then you need a larger mount to hold it, and then also control its speed, also control while it's tracking. So the mount also becomes bigger, that means the platform becomes bigger, and so on. Okay, now, and of course, to automate all this, to have a control over this, and start the imaging and targeting, we will have to have a PC or a small computer with us. And of course, for post processing, we will need a computer where also once we have the raw images, we can be at our home or comfortable place and do the processing of the image. So we will also need a computer as part of this. So this setup, what I'm showing you is the setup that I use. This is my setup. So if you see here, this is the telescope. This is much smaller than the one you see here. This is a Newtonian telescope. This is a refractor telescope, and this is the special camera which we spoke about. Yes, and this is mounted on a plate, and this is the one that is similar to this. This is from a different company, and it has a slight different principle in the way it works. Centrally mounted. That we don't have to go into those details now, but you have questions if you're interested to know what this is, please feel free to contact me. And there are some weights to counteract to whatever we are loading here. You can also see the weights here. It is also there. And do you see that I have two telescopes? This is one and this is two. Any guesses why we wanted to have the second one? And that's also smaller than this. Yeah, I heard somebody say guide. Yes, this is basically the guide scope. Okay, a finder scope, you use it during your visual astronomy, where you wanted to you wanted to guide your actual scope. So a guide scope will basically be having a wider field of view. So if you are aligning the the finder scope with your main scope, and if you are able to locate a star, you will also see it in your main scope, right? Likewise, this is for the photography. So what it does is it does tracking, it does accurately try to track, but of course this is also a machine, and it is in real world we'll have a lot of tolerances, right? So that way the tracking could also go a little off, little here and there, but a little off here and there will also be clearly shown in the image. A little off meaning instead of showing the stars round, it will be showing the stars like an ellipse or something like that. It will not be showing it wrong. So it is very, very important that we drive the motor drives it very accurately so that we get a beautiful image or a very clear and crisp image. For that, this is not possible by, this is basically there for a feedback. This becomes a closed loop system. What happens is now wherever this telescope is seeing, this is also seeing the same place, but since it's having a wider field of view, it will be seeing more space. So I will lock a star, I will lock one particular position with this, and while this is trying to do the imaging, if it sees that okay, I have to move 10 steps but I moved only 9, if I'm missing one step, this will tell that yes, one step has been missed, and it will send to you, and then this during this imaging only it will do a course correction. But basically this makes the open loop system. Can I do a imaging without this? Yes, definitely possible. But the thing is, you will not be able to get an accurate image. What it does is, if the entire system has a little bit of an accuracy issue during the imaging time, this helps you to course correct it during the imaging. So this helps us in overall we get a better image. So that's the reason why I am mounting this. That's why if you see in the previous discussion, I did not exclusively talk about this, because with and without this, still it is theoretically or technically possible to do an imaging, but it helps us to improve the imaging significantly. Okay, and of course, like I told you, in order to control this, I have a small computer here, and this is just a battery bank to connect and operate this over the entire whole night. Again, this location is also from Coorg, where we had our last star party, and this was from December last year. Okay, and what are, you see some strips? Here are some strips. There are two strips, this black one. Do you know what these are? Any guess? These are nothing but the dew heaters. See, we are in the middle of a jungle, and lots of flora and fauna around. So that means a lot of dew is getting coming up. There were days where we don't even see people little far off from us. So much of dew is there in the early evenings, and this dew heater, if this is not there, what happens? The dew comes and settles on the telescope. Okay, and then this means that completely blocks the light's entry. So once if you have a dew heater and this is on, this will give you a mild temperature. It will keep a small, I don't know, maybe around 40 degrees, something like that. It'll be all it'll keep the telescope area, that area, in the warm. So that means that the dew will not come and settle in that place. So you'll always see that. So this problem of dew can be wide. This looks like a simple piece of equipment, but if I go to Coorg and I forget this, I have to forget imaging. It's a very important piece of equipment, though it doesn't, if you convert that into value for money, probably it's one of the most valued equipment value for money, the neonatal gets the highest. That's a very important piece of equipment. And any piece of equipment is very important. You cannot forget this. You cannot forget any piece of equipment. Sometimes, if you are lucky, you get it from your fellow astronomers who are coming there. If you are not lucky, just close the box and look down. Okay, so that's typically about the setup. Okay, one of the best friends of astrophotographers, I would say, is Orion Nebula. Probably most of us, I cannot say all, but many of us, most of us would have started our imaging of nebula. That would have been definitely with Orion, for the very reason that it is easy to identify, and also it's bright. I think the magnitude. Any help with the magnitude numbers for Orion? Five something, around five. It's a bright nebula, and in a very good dark sky, you will be able to see its nebulosity with naked eye also. And in the binoculars, it looks fantastic. So that's the reason why most of us will start with this. And this is not my image, by the way. This is by one of our fellow past members, Ganesh. He's not here today. So it is with his image, with this setup. So the Skywatcher EQ6R mount is nothing but the model name of this mount, whatever you see here. This mount, this entire setup. And the telescope he used is an 81 mm refractor. 81 mm. The number means basically the aperture, the size of the light bucket, or say the dia of the light bucket. An 81 mm refractor is something like this. Same, this is also an 80 mm refractor, but whatever he has is a different from a different manufacturer. So this telescope on that setup. Also, do you remember we saw the Orion and the Horsehead Nebula in one image, in a wide field image? So these are the close-up images of that. So different setups can give you different field of views. Okay, so the bigger light bucket can give you a close-up field of view. So this image was taken by me with that exact setup what I showed you in the previous page. This image was taken by me. This is the Pleiades or the Seven Sisters. This image is from Subhendu. The only thing is the setup is not allowing us to see the image. Okay, we will resume from Pleiades. This is where it dropped, right? Okay, we are still dropping. Yeah, this is Pleiades taken by Subhendu. Again, this is also from Coorg, if I'm not wrong, right? Hanle. Okay, this is from Hanle. Next time I'll also add the location. So this was taken by Amber. This is called Thor's helmet. Like it looks like a helmet, right? If not, also you have to say yes, it looks like a helmet. So this was taken by a much bigger or a bigger setup than this. It's called an Ioptron Sen 70. Whatever I showed you, the setup which I had was called, it's called Ioptron Sen 40. This is a much bigger setup, and the telescope which we used is also a bigger one. It's a 10-inch SET, Schmidt-Cassegrain 10-inch telescope. That's a bigger telescope, meaning the payload is even bigger. And overall, it's a beefier setup than what we have used to. Again, the Pillars of Creation by Amber with the same setup. This one is by Subhendu. So this is the, sorry for that small break. So like, yes, I have written Saturn Jupiter conjunction. So what does this mean? That's in the sky, Saturn and Jupiter came very close. Does it mean that they have been close? Meaning, are they so close that somebody from Saturn can wave a hand and show it to somebody in Jupiter? Is it that way? In the morning it was explained that they don't have to be in the same plane, of course, right? So in this image, they are coming in the same field of view. When I'm seeing from here, I'm able to see it in the same field of view. It doesn't necessarily mean in the other dimension it's in the same. So it could be like this, it could be like this, right? But when I'm seeing from here, in my 2D plane projection, these are the same. That's what we see. And that's
So that should make a link to you. But can you understand what this means, this image means? You have the clue in the topic itself, but yeah, let's give it a try. You have three moons, yes, and of course we saw the moons in the other images also, right? One of them is on Jupiter. Yeah, you see that shadow, right? So that dark black round spot, that's actually the moon that is transiting into Jupiter. So exactly when it was transiting, this image was taken. And by the way, with the stellarium, you can zoom into Jupiter and you can change the time and see when this transit will happen, and then based on that you can plan your observations. So stellarium will help you, sky safari or stellarium. I think we use stellarium in the morning. Yeah, stellarium can help us exactly see this at what time this can happen, and based on that we can plan our sessions. That's how we end up in also making this image, because we know when this is calculatable, right? So it is on a path and it is on a velocity, and that means we can establish a function, and then we can understand when and where these moons will be. This can be easily calculated. So this is how, that's why this is special. Okay. By the way, this was taken by Ogli. He's not here again, one of our class members. So this was taken by Kirti. So do you know what this is? Of course, I wrote it on the top again. Next time I will see that I will read the topics first and then ask you questions. So this is Comet Neowise, taken from Paris, and you can see how beautiful it is. This again taken by Subhendu. So this was using the small simple setup. Where it is? Yeah, okay, you don't have it here. A small simple setup, like just camera and a tripod, and you will, of course, if it's a solar eclipse, what's more important? You should have the solar filters different. As you had the solar activity, you saw in that big telescope, right? The Newtonian telescope, you had a silver kind of a foil on top of it. So that's the solar filter. So we have customized solar filters for camera also. So have to mount it in the front, put it on the tripod, aim it at the sun, and then use your intervalometer or something, start capturing the signals, and you will end up with a barrage of images, and from that pick the ones that best suits for this kind of showing the transition, and then use that. This is also
so. This is the solar eclipse that we had in 2020. Is this partial or a full eclipse? Okay. That was easy, right? Which location was this, Subhendu, by the way? Bangalore only, no? See, Bangalore offers us a lot of. Of course, for like I said, you have the right equipments, and if it is not cloudy and at that point in time, if you have the planets coming up, planetary imaging is very well possible within Bangalore style image. You don't have to really go to a dark space for capturing planets. This makes it a little easier, or it makes it a little easier compared to what we have to do for DSOs. For DSOs, we'll have to spend 2 nights, 3 nights together, take those images and come to this level. But for planets, it doesn't really require that much of timing. Yeah, just the continuation of it. Now you see how it was done. Subhendu, will you start from here? Okay, now I will give it to Subhendu. Thanks for your time. We had some glitches, but yeah, we made it. If there are any questions, please feel free to ask any of us. You can also put it in the Telegram, or you can also, I'll be here, of course, until the end of the workshop. So if you have anything that you wanted to discuss, please feel free to ask to any of us. Thank you once again. It's a big problem.
Issues. Just a quick introduction to Subhendu next. He's going to talk about star trails. Once you see the pictures, you'll understand what exactly is a star trail, what equipments we are using it, and how to get it. So he's a software engineer by profession. As a hobby, he is into astronomy and astrophotography. So he's also recently got married. A little secret of his. So I got to know his wife gifted him a very nice mount to take nice pictures, which he's going to talk about as well. This side? Start. Yeah, hi all. So I will be talking about how to take a star trail photo. So basically, star trails show how the stars are moving in the night sky. Okay, is it? Am I audible now?
Hello, hello.
Audible now? I have to speak closer. Yeah, fine. Next is this, right? Fine. So star trail image shows how the star is moving in the night sky. So you can capture a long exposure of it and then just stitch them together to see nice patterns. It's the same pattern, but yeah, it looks nice. So what kind of equipment do we need for this? So the first is just a basic, yeah, camera. That can be a DSLR or a phone camera also. Not something hi-fi astro cool cameras. And the second thing is that we need is a tripod, which will just stabilize the image so that the shots are in the same frame. So basically, we just follow some basic rules. The first thing is to frame the target. We can have a nice foreground object to have there. Huh?
Back there, can you have in the back there, can we have a little bit of silence, please? Thank you, appreciate it.
Thank you. Yeah, so when we are framing the target with for a star trail image, so we have to think about some nice foreground object. That can be anything. Some folks take it with some historical places or some object in the ground only, normal. So yeah, so first, one thing you do is just take some few test shot so that you can get some nice number of stars in a single image. And when you have got that, then you just take a lot of images and don't
put a break in between the images. So you just capture lots of images. Let's say 200 or 300. How long you want to take the star trails, and there is a bonus tip is to uh, reduce the exposure by a little bit so that the star will have a nice color to it. So right now I will just show a simple demo of how to post process the image and get the star trails. It is showing here.
We need to move the screen to stop the PPT.
Okay.
Yes.
Stop it or just end /2.
Inside. So
Okay.
Video.
now we need to put the
No,
star
no.
trails into the screen. Just drag this.
Where?
All right. Drag it.
So this is a free and basic tool which I have used. There are many of them like this, but yeah. So I will just. So I have selected a few star images like this, and to process it, I will just go here. Oh, sorry, it started already. Wait. No. Yeah. So there is some setting that we need to do. So first is just to change the blending mode to either lighting or gap filling, and there is an option of comet mode. I will show this in a separate slide. And yeah, after that you can just start the processing, and you can now see the star trails showing up. So you can see the stars are moving in this path. There is a nice curved thing. Can you see the foreground object? Can anyone say what that is? The foreground object. It's a dead tree. Yeah, so it was not lit up. It is not showing up very brightly here. But yeah, so if you see here, some of the stars have some kind of colors to it. Yeah. Can anyone tell what is that star color mean? Anyone? Please say it louder. Yes, the temperature and about the size of the star also, right? So the bigger stars will burn the gases very too much, and then it will light up brightly. So the blue ones are the most hotter ones. So yeah, let's go back to the presentation. So it's in the common mode. So this is the final image from that, the one that I was trying. So you can see that there are some of the blue stars are there. There are some yellow. There are some red stars. Can you tell me what is the star at the center? Oh, star. Why it is not moving like the other ones? Okay, because it's on the similar axis to what Earth is rotating on. So that's why it will appear to be fixed. Also, if I tell you that each of the star trail is subtending an angle of 15 degrees, can you tell me how long was the duration of the star trail? 1 hour. Nice. Yes. So this is one more image, star trail image taken by Snehith in Hanle. If you can see that you can see both sides of the curvature. So there is one in the bottom and there is one at the top. There are some stars with lights, but yeah, this is a nice image. And yeah, can you tell me what is this image? This on the left? Can someone say? So that was Venus. So this was taken very early in the morning. So Venus was just rising up here. This is one more. So this is where Snehith has tried to frame it with a pole star on the on a pole. So it's kind of funny. And on the right, you can see a small structure. So that is the Mace telescope in Hanle. So on bonus tip, so since you have taken a lot of, if you try, so you will have to take a lot of images for this one. So you can use the same images to create some nice time lapses. So one example of this is here with the same image. I can take some time lapses, which Mahadevan is very well known for. This is just a small one. So I talked about a comet mode in the yeah. So comet mode in that star stacks tool. So you can get the image and just have some different kind of time lapses, which will look like this. Can someone tell me what's the big dense structure there in the center? Is this the one? Oh. Yeah, that is what I'm thinking. Yeah, this structure. Can anyone say what that is? That's a star cluster. So bunch of stars which are very nearby, and that looks like this. So yeah, with this I finish off my talk. I will give it back to Snehith for next one.
Thank you, Subhendu, for that. So one thing you understand regarding star trails is you don't need a fancy setup. So if you have your phone and a nice tripod, take the pictures of the stars, use the StarTax, which is a free software. You can do the blending mode or the comet mode, just like what you saw, and you can get these star trail images by yourself. So for kickstarting something that you would like to do regarding astrophotography, star trails is a good way to start with it.
What's the score? 357.